Have you ever thought that a small, dim star, just 6 light-years away from us, could be the key to unlocking billions of years of the Milky Way's history? Join Cosmos Adventures as we explore Barnard Star, the oldest red dwarf near the solar system, which has just revealed the mysterious planet Barnard B, opening a new chapter in the hunt for worlds beyond. Located in the Ophiuchus constellation, approximately 5.96 light-years from Earth, Barnard Star is the closest solitary star to us, surpassing Proxima Centauri, which is 4.24 light-years away and belongs to the Alpha Centauri triple star system. With an estimated age of 10 to 12 billion years, twice the Sun's age of 4.6 billion years, this is one of the oldest stars near the solar system. Classified as an M4-type red dwarf, it has only 16% of the Sun's mass, equivalent to 3.182 × 1029 kilograms, a diameter of 19% of the Sun's, approximately 132 million meters, and an extremely low brightness, only 0.0% of the Sun's luminosity. Its surface temperature is around 3130 Kelvin, much cooler than the Sun's 578 Kelvin, causing it to emit mainly infrared light, making it invisible to the naked eye. Barnard Star is famous for having the fastest apparent motion in the night sky, with an angular velocity of 10.39 arcseconds per year, discovered by Edward Emerson Barnard in 1916. This means that after 180 years, it will have moved an angular distance equal to the diameter of the Moon in the sky. With a true velocity of 140 kilometers per second relative to the Sun and approaching us at a speed of 110 kilometers per second, by the year 11,800, it will be just 3.85 light-years from Earth, temporarily becoming the closest star to our Sun. According to NASA's 2023 report, this rapid motion is not just an interesting trait, but also helps astronomers easily detect slight oscillations caused by planets. Combined with its rare stability, Barnard Star becomes an ideal target for searching for planets orbiting the solar system. Before we dive into Barnard Star, let's first review some knowledge about red dwarfs. Red dwarfs are the most common type of star in the Milky Way, making up about 75% of all stars in the universe. With masses ranging from 0.08 to 0.6 times that of the Sun, they are the smallest stars on the main sequence of the Hertzsprung-Russell diagram, a tool used to classify stars based on brightness and temperature. Unlike the Sun, which is a G2V-type star, or giant stars like Betelgeuse, red dwarfs sustain their energy through slow hydrogen fusion in their cores, where 4 hydrogen atoms fuse into 1 helium atom, releasing 2 positrons, 2 neutrinos, and 26.73 mega-electron-volts of energy. Their core temperatures range from only 3 million to 10 million Kelvin, much lower than the Sun's 15 million Kelvin, causing fusion to proceed slowly. This also means that their lifespans stretch into the trillions of years, far exceeding the universe's current age of 13.8 billion years. According to scientists, no red dwarfs have yet reached the end of their life cycle, as they have not had time to exhaust their hydrogen and collapse into white dwarfs. This makes them eternal witnesses, preserving information about the early stages of the galaxy, from the moment primordial gas clouds began forming stars. Returning to Barnard Star with a luminosity of only 0.20004 times that of the Sun and a mass approximately 0.16 times that of the Sun, it is a typical example of an M4-type red dwarf. Among red dwarfs classified from M0 to M9, M4 lies in the middle, with moderate size and temperature compared to larger red dwarfs like Gliese 581 M3 or smaller ones like Proxima Centauri M5.5. It lacks the energy to fuse heavier elements like carbon or oxygen, unlike larger stars that undergo complex fusion processes before exploding as supernovae. When its hydrogen is depleted after trillions of years, Barnard Star will shrink into a white dwarf without undergoing a violent explosion, a peaceful fate compared to the giant stars out there. According to available data, an interesting fact is that Barnard Star has low magnetic activity and fewer plasma eruptions compared to many other red dwarfs like Proxima Centauri, which frequently emit strong energy bursts that interfere with observational signals. According to Astronomy and Astrophysics in 2024, This stability is a significant advantage, reducing interference when scientists search for planets using sensitive methods such as radial velocity. This, combined with its proximity to Earth, makes Barnard star a natural laboratory for studying red dwarfs and their planetary systems. Barnard B, a tiny planet in an ancient star system. After over a century of observations, in 2024, scientists confirmed the existence of Barnard B, an ultra-small exoplanet with a minimum mass of 0.37 times Earth's, approximately 2.2 × 10^24 kilograms, equivalent to 3 times the mass of Mars. This discovery, published in Astronomy and Astrophysics in October 2024, was based on 156 observations from the espresso spectrograph at the Very Large Telescope in Chile, with a precision of 10 centimeters per second. Barnard B orbits the star with a period of 3.15 days at a distance of 0.0229 astronomical units, or 3.426 million kilometers, about 20 times closer than the Earth-Sun distance. Its orbit was also confirmed through a physical law. The square of the orbital period is proportional to the cube of the distance from the star, divided by the product of the gravitational constant and the star's mass. Specifically, a period of 3.15 days, equivalent to 272,160 seconds, matches the distance of 3.426 million kilometers and Barnard star's mass of 3.182 × 10^29 kilograms. However, this close distance places Barnard B outside the habitable zone, where liquid water could exist. Its equilibrium temperature is about 438 Kelvin, 165 degrees Celsius, calculated based on the star's 31 and 30 Kelvin temperature, its radius of 132 million meters, a distance of 3.426 million kilometers, and a light reflection factor of 0.3. This high temperature, caused by the close orbit and the relatively strong brightness of Barnard's star, makes Barnard B a scorching rocky planet, unsuitable for life as we know it. The search for planets around Barnard star spanned over 60 years, starting in the 1960s when astronomer Peter van de Camp used astrometry, measuring minute stellar movements in the sky, to detect wobbles suggesting 2 giant planets. He published this discovery based on hundreds of photographic plates from the Sproul Observatory, but in 1973, George Gatewood and John Hershey demonstrated that these wobbles were due to optical errors from telescope lens changes, not planets. This was an important lesson in astronomical precision, driving the development of more sensitive instruments. By 2018, a 233-day periodic signal was detected using the radial velocity method, based on light color shifts due to the Doppler effect, suggesting a super-Earth 3 times Earth's mass. However, studies in 2021 and 2022 refuted this signal, showing it matched the star's 140-day rotation period, likely caused by star spots or magnetic activity. In 2024, Espresso, an advanced spectrograph, provided a breakthrough, confirming Barnard B's oscillation using velocity calculations involving gravitational constants and orbital inclination. With oscillations of just a few centimeters per second, Barnard B was confirmed, along with 3 potential signals with periods of 4.12, 2.34, and 6.74 days, hinting at a compact planetary system around this ancient star. Red dwarfs are the backbone of the Milky Way, with an overwhelming number and an important role in the search for extraterrestrial life. According to Nature Astronomy in 2023, about 40% of red dwarfs may have planets in the habitable zone, the region where temperatures allow liquid water to exist. However, due to their low luminosity, their habitable zones are very close to the star, usually only from 0.02 to 0.1 astronomical units, making planets easily tidally locked, with one side always facing the star, causing extreme temperature differences between the 2 hemispheres. Barnard's star also has a habitable zone, estimated to be between 0.06 and 0.12 astronomical units, but Barnard B, at only 0.229 astronomical units away, is too close and too hot to support life. Barnard's star is also unique in its metallicity, the ratio of elements heavier than helium, ranging from 75% to 125% compared to the Sun, according to Astronomy and Astrophysics in 2024. This suggests that it belongs to an intermediate stellar population, formed during the transitional phase of the Milky Way, possibly from the remnants of an ancient supernova. The discovery of Barnard B proves that even ancient stars with limited material resources can still form planetary systems, a step forward in understanding how small worlds form around red dwarfs. With a distance of only 6 light-years, Barnard's star is an ideal target for advanced telescopes. The James Webb Space Telescope, JWST, launched in 2021, can analyze Barnard B's atmosphere in the infrared spectrum, searching for molecules such as CO2, CH4, or H2O, potential indicators of an atmosphere or geological activity. JWST uses a 6.5-meter primary mirror and the ability to observe through cosmic dust, providing more detailed images than any previous telescope. Meanwhile, the extremely large telescope, ELT, with a 39-meter primary mirror, is expected to be completed by the end of this decade in Chile, enhancing the ability to detect small planets and study their surfaces, according to ESO in 2024. ELT has 100 times the sensitivity of current 8-meter telescopes, enough to distinguish planetary signals from stellar noise. Additionally, projects like TESS, Transiting Exoplanet Survey Satellite, and Plato, Planetary Transits and Oscillations of Stars, may also contribute to studying Barnard's star in the future. TESS, operating since 2018, specializes in detecting planets using the transit method, where a planet passes in front of a star, causing a dip in its brightness. Plato, scheduled for launch in 2026, will expand the search with higher precision, focusing on nearby stars like Barnard's star. These instruments promise to reveal even more secrets from the Barnard system, potentially including undiscovered planets in the habitable zone. Barnard's star is not just a fast-moving red dwarf or a newly discovered planetary system. It is a bridge between our cosmic past and future exploration. Barnard B, though uninhabitable, is the first step in the journey to finding second Earths. Join Cosmos Adventures in continuing this adventure. Hit subscribe, turn on notifications, and don't miss any of our videos. See you in the next video, where we'll uncover more mysteries of the universe. Thank you.